In this lesson, we're looking at the gradient formula. So the gradient formula we know is rise over run, but it can also be classified or spoken about as saying the change in y over the change in x. And another way we can write that is our y2 value minus our y1 value over our x2 value minus our x1 value. So looking at that second y value and subtracting the first, and that second x value and subtracting the first x value. So if we find the gradient of each pair of coordinates below, we look here and we're going the change in y, so change in y over the change in x. And if we think this is x, this is y, x, y, this is my first, this is my second. If I'm looking at my y values, I have 8 minus 10, so the second take away the first, and then 6 minus 4, so the change in y and the change in x. This gives us negative 2 over 2, which would just be negative 1. So the gradient of that line is going to be negative, and it is then a steepness of 1. So similar here, m is, if this is 1 and this is 2, x, y, x, y. My second y value is 2, my first y value is 1, my second x is 5, and my first x is 1. So 7 minus 1 is 6, 5 minus 1 is 4, and then we just need to simplify that fraction. And if we look at our last one, we take our second y value, which is 3, subtract our first y value, which is 3, subtract our second x value, subtract our first x value, which leaves us with 0 over 3. And if we have 0 as our numerator, that simply just means it's going to be 0. It doesn't matter what that denominator is. So that would mean we would have a flat line or a straight line. There is no gradient to it. So how do we find the equation of a line from a table of values? Well, first of all, we need to find the gradient, which is what we've just been doing in the previous example. We then put that gradient into our formula y equals mx plus c. This is our equation of a straight line, or a linear equation. We substitute a point from the table into the formula to find c, because we will have our x and y values from our table of values, and then we rewrite the formula with the values of m and c included. So if we look at this first table, I have y equals mx plus c. That's what we're aiming to find. I need to firstly find my gradient. So I need to say my y2 minus my y1 over my x2 minus my x1. So if we pick a set of values, okay, and then this can be my first set of values, so this is 2, this is 1. My second y is 25, my first y is 10, my second x is 6, and my first x is 1, so that gives us 15 over 5, which is 3. So if we're then using this formula, that means my gradient, which is m, becomes 3. So 3x plus c. What I then need to do is substitute in one pair of these coordinates. It doesn't matter which pair you pick, usually the smallest, or if there's negatives, we try and pick ones without negatives to make it a bit easier. But if I'm going to use this first one, I'm going to use x as 1, y is 10. So everywhere I see a y, I'm putting 10. And everywhere I see an x, I'm putting 1. And then I'm trying to find c. So this is 10 equals 3 plus c. To get c on its own, I need to solve my equation. So that tells me that c is 7. So then if I put it all into this equation now, I end up with y equals, my gradient is 3, and c, which is my y-intercept, is a positive 7. So that's how we find the equation of a line just from a table of values. So if we look at this second example, we need to still find our gradient. So it's our y2 minus y1, x2 minus x1. Again, pick a set of coordinates. This is my first, this is my second. So I'm going to say, well, negative 16 take away negative 1, and then it's going to be 5 take away 2. So negative 16 take away, that makes a positive, so plus 1 gives us negative 15 over 3, which tells us our gradient is negative 5. So if I put this into our linear equation formula, or our straight line formula, and then I'm going to pick a set of coordinates again to pop into the x and y values. I'm going to use the first one again, it's the simplest. So y is negative 1, negative 5 times x, which is 2, plus c. So negative 1 equals negative 10 plus c. I need to eliminate the negative 10, so I add 10. Negative 1 plus 10 is 9, which is c, so that's our y-intercept where that line crosses the y-axis. And then I rewrite my formula. So I get negative 5x plus 9.